What is up, beautiful physics people? This is the equation review. This week, we have a whole new equation for you. Let's learn it. Let's go back to the beginning, however. When something is moving, it has a velocity, right? And that velocity is equal to its displacement divided by its time. This is the most basic of kinematic equations. It describes speed, which is its velocity when you include the direction. Everything moves in a direction in real life. That's called its velocity, its speed, and its direction. That is displacement divided by time, how far it's gone from its origin divided by the time it took to do so. But hardly anything stays at a constant velocity, right? Forces act on us. We speed up, we slow down. So when we do that, we change our velocity and we call it acceleration. It could be positive, it could be negative. And those are not just plus signs and minus signs. Those exist in real life. Those concepts are real, right? It's speeding up in one direction or slowing down in the other direction. That is what this sign means. So we're talking about acceleration. We're talking about change in velocity, that delta, change in velocity over change in time. As time changes, how does my velocity change? Does it go up? Does it go down? Does it change direction? That's what we're going to be talking about today. How do I change my direction, right? What does that mean when I change my direction? We're going to be talking about that today. This is our first acceleration formula, delta V over t. This is the same thing as saying, I have one velocity, I subtract it from another velocity divided by time, right? As time changes, I started at one velocity and ended up at another, and the difference, the delta, is the change in velocity. It could go up, it could go down. If you see that this number is bigger than this number, it's going to be positive. If you see that this number is smaller than this number, it's going to be negative. Because in real life, that's how it works, right? If my initial velocity is slower than my final velocity, I have increased. If my final is slower than my initial, I have slowed down. That's what that sign means. Let's go. Don't be freaked out if it's negative. And the problem, are you slowing down? Then it should be negative. Let's go. So what if I don't have my time, however? What if I do not know t time? No sweat. Acceleration is also equal to final minus initial. If I square those, I don't have to use time. I can say 2 times the displacement is equal to the acceleration. That's final squared minus initial squared over 2 times displacement. This is another way to find something's acceleration. Let's go. There's one more that I want you to know. You have to know this one. It's super useful because if I wanted to find my displacement and I didn't know my final velocity, but I knew my initial velocity, whether it's at rest or I'm already moving, if I know that and my acceleration, my time, I can figure out displacement quite easily. It's initial velocity times time, right? Initial velocity times time plus 1/2 times acceleration times time squared. Again, that's initial velocity times time plus 1/2 of the product of acceleration and time squared, right? Not time squared like in New York, t squared, y'all. If you type it in there just like in your calculator, you substitute, right? Given, unknown, equation, substitute, solve. Given, what am I given? Unknown, what am I looking for? Equation, which one of these am I going to use? Substitute, plug and play, solve. It's the easy part. You get it right every single time. But you can't do it unless you know them. You know what I'm saying? They're always on the agenda. They're always given to you. You have to memorize them. They're here for you. Let's go one deeper. Let's go one more. Well, we talked about changing velocities, right? Well, to change my velocity, I can speed up or I can slow down. We call that acceleration, of course. But remember, acceleration is a vector, just like velocity is a vector. It has magnitude, right? It has the speed, but it also has direction. What if I change my direction? What if I change my direction? That's what we're going to be talking about today on my Loom. Click below this, start that Loom activity, and learn something. Let me show you the formula real quick you're going to be working with. It's right here. It's always going to be here. So if I change my direction, let's say I'm going in a constant velocity this way, and that direction is east if you didn't know. We're going to call this my velocity, right? But what if I turn, like I'm in my car, and I turn, right? I turn. And I keep doing so, and I turn, and I turn, and I turn, and I turn. Guess what I'm going in? A circle. We call this uniform circular motion, or UCM, and going in a circle. My velocity stays the same, but I'm still accelerating because I'm changing my direction. The other part of it, remember, I taught you vectors and scalars. Vectors have a magnitude, a speed, and a direction. Look at me changing my direction here. I'm changing my direction constantly. So while velocity goes out, and we're going to call that tangential velocity, I'll tell you what that means in the loom. And where is our acceleration? I'm not accelerating that way. I'm accelerating towards the center of the circle. And we call that A sub C. What does the C stand for? Look at it in the loom. Check it out. I'm going to teach you everything. So this car is going to continually go in this circular path where its velocity is pointing in different directions, but acceleration is always pointing towards the middle. That's right. It is accelerating towards the middle. And it might be going the same speed the whole time, maybe 2 meters a second, but it is still accelerating towards the middle. That's how it's turning. Let's go. What's the equation that describes this acceleration? How do I figure out? This is one of my favorites. My acceleration, sub C. What does the C stand for? Check my loom. It's called centripetal acceleration. Check the loom. A sub C, this circular acceleration, centripetal acceleration, is V squared over R. Guess what R is, homie? That's right, it's the radius. Half the diameter of the circle. This right here, the radius. Square the velocity divided by the radius. It will tell you the acceleration of circular motion. This is the only formula that you need to know right now. Let's get it. This is week 7. I want you to pay attention to my loom. I want you to do the quick check. Do not wait. Hop on there. It's too easy. Let's go. Loom presentation below about uniform circular motion. Let's get it. Bye.